y equals the inverse sine of x. I want to find dy dx. Let's see what this is equivalent to. I believe this is equivalent to saying x equals the sine of y. Yep. X equals the sine of y. So what I want to do is find dx dy, take the reciprocal of that, and then try, if I can, to write it explicitly in terms of x. Finding dx dy is no problem. Taking the reciprocal of that is no problem. The challenge is to write it explicitly in terms of x. What is dx dy? Maybe even simpler than it seems, or as simple as it seems. It's cosine y, just like that. And because we're differentiating with respect to y, that variable matches the variable in the argument. We don't have to multiply by d anything. It's just cosine y. But if I want dy dx, dy dx is the reciprocal of this. Dy dx is 1 over cosine y. But what's y? Y is the inverse sine of x. And this is the challenging part. This is 1 over the cosine of the inverse sine of x. So we need an expression for that in terms of x. So it's right triangle time. It's right triangle time. Off to the side, off in the margin somewhere, we let theta. We can actually do this with y, but sometimes we don't think of y as an angle. So I'm going to go with theta. Theta equal inverse sine of x, so the sine of theta equals x. So here's theta. And if the sine of x, sine of theta equals, let's say, x over 1, let's write x as the side opposite and 1 as the hypotenuse. What would be the length of the other leg? The square root of 1 minus x squared, 1 squared minus x squared. The square root of 1 minus x squared. And if that's the case, what is the cosine of theta? The square root of 1 minus x squared. So here we go. 1 over cosine of inverse sine of x is going to be 1 over the cosine of theta. So that's 1 over theta as we've defined it up there, 1 over the square root of 1 minus x squared. So this is an expression for the derivative of the inverse sine function, 1 over the square root of 1 minus x squared.